Hi everyone! So I wanted to go over these pre-lecture notes for Module 2. Just a few things that'll probably be about 5 to 10 minutes that kind of get us through some of these easier topics and then gives us a little more time in class next week for the rest of Module 2. So the one thing I wanted to talk about were stem and leaf plots. They also can be called stem and leaf graphs or stem plots. It's a good choice for small data sets. We would not do this with a large data set, but it's a way that we can show graphically what a data set looks like. So we separate the numbers into what we call a stem and a leaf, and the leaf is the smallest digit that we have, which has to be the same place value for all the data. So it would be the ones place or the tenths place. It'd have to be data that all goes to the same place value, and then the stem is all the other digits. And we put them in order, and then we can really see where, which kind of areas have the most data. So in this example, we said students counted how many worms they found in the school parking lot each school day for the past 3 weeks. Their data is below. Draw a stem and leaf plot for the data. Remember to include a key. So in this case, the leaf is going to be the ones place in each case. It's the smallest digit that we have there, and then the stem is going to be the tens, and some of these have hundreds as well. Okay, so that's where we're going to split up these numbers. So I'm going to make a little chart, and my stem goes here and my leaf goes here. And you can label those if you'd like, you don't have to. But here's our stem and our leaf. And we're going to put them in order. So we're going to look for the smallest value that we see. And the smallest value here is 45. So for 45, I'm just going to kind of mark it off so I remember that I've used it. My stem is going to be 4, and my leaf is going to be 5. Now, my stems are going to go in order. So this is the 40s, then we'd have the 50s, 60s, 70s, and so on. So I don't have any more numbers that are in the 40s. I do have one that's in the 50s. So I have 59. And then I look and I have no more 50s, but I have one 60, which is 68. Now I have no 70s, no numbers in the 70s, but I still need to put my stem there to show that we're skipping that decade of numbers. And I'm not going to put anything here. I'm not going to put a 0 because that would look like it was 70. Then next I have 8 for 80s. So I notice I have 83, 84, 83, 86, 84. So I have quite a few in the 80s. So here's what I'm going to do with those. My smallest is 83. Then I have another 83, so I put another 3 there. So each of these leaves makes a full number with the stem. So 83, 83, then I have 4 for 84, I had another 4, and I had a 6. So I can already visually see that I don't have as many numbers, 40s, 50s, 60s, I have none in the 70s, I have a bunch in the 80s. So now I move on and go to the 90s. Now, if you were doing this, you can check them off as I'm doing, or you may even want to write them in order to start with to make sure you're not missing any. So 90s, I have 92 and another 92. So my 9 goes here and my 2s go here. You want to keep the leaves lined up like this. So all the first leaves are in a row, the second leaves. You can even use something like graph paper because you want that visual reminder of which of these stems has the largest number of leaves. So I have 10, which is going to represent 100 something. And I notice when I look at this, I have things all the way up to the 120s. So I'm just going to go ahead and put those in for now as my stems. So in the 100s, I have 100. I have 103 and I have 107. So I have 0 for the 100, 3 and 7. And then for the 110s, I have 115 and then I have 125. So again, it looks very visual. I can see where the largest number of values are. Really, if you turn it, it almost gives you a bar graph here, right? Kind of showing, okay, 40s, 50s, 60s, the 80s are the highest, 100s are the next highest. Now it did mention that we needed a key, so we need to somewhere include a key that shows what I'm doing here, because 4 with a line and then 5 equals 45. The reason we need to do that is because if instead of this leaf being ones, let's say the leaf were the 10ths place, we would not put the decimal in here. So it would look the same if it was supposed to be 4.5 or 0.45. So we need to put a little key in just to show which place values are what. There's another question down here. It says, on what percent of the days did the parking lot have fewer than 85 worms? So this is not part of the stem and leaf plot, but it's just another question with that data, kind of reminding you about percent. So fewer than 85 worms, well that's 1, 2, 3, 4, 5, 6, 7. So 7 days. That's how many days the parking lot had fewer than 85 worms. But it asks about percent. So when we count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 days in all. So the percent is going to come from 7 out of 15. We can change that into a percent by dividing. So 7 divided by 15 is going to give us a decimal, and then we can round that over to a percent multiplied by 100. It doesn't say what to round to, so this gave us 0.466, right, going on forever, 0.46 repeating. You might see it like this. As a percent, we could say that is 46.7%. We could say it's 47%, depending on what you round to, which is not specified here. Okay, let's look at the next page. There's another example of a stem and leaf plot. Okay, so 10 kindergartners, distance from home to school. Now in this case, our leaf is going to be the 10ths place and our stem is going to be the ones place. So we see that our ones place, these are in order this time, so that helps, goes from 0 up to 8. So we need to have all of those stems in here. And then we're going to put our leaves. So 2, 1.0 and 1.4, 2.9, 3.1, another 3.1, a 3.2 and a 3.3, 4.2, and then 8.1. We want these all here to show that there's this gap where there are no numbers, and again we can visually see where the most common values are. So for this one, and you don't have to use the first value in your key, you could use any value. I could say 3.1 is equal to 3.1 in this case. So we know where that decimal point is. Alright, an outlier or extreme value is a data value that does not seem to fit the rest of the data. We'll talk about them more later on and have more formal ways to figure out what is an outlier. But in a stem plot, they can be easy to spot, so you can see which one is farthest away. Obviously, we see here that 8.1 could be an outlier. It looks very different than the rest of the data. Okay, the last thing we're going to talk about here is mean, median, and mode. Those are generally things that people remember from other classes. If you don't, that's okay. So mean is what we often talk about as average. So to find the mean or the average, we add all our data values. It's the first thing we do, and then we divide by the number of data values. So if I have 10 test scores, I add them all up and I divide by 10. And we'll do an example in a minute. And of course, if you are not quite done writing, you can always pause the video for a second. To find the median, we put the data in order from smallest to largest. That's an important first step. And then we find the middle value. So this is if there are an odd number of values, or the mean of the two middle values, and this is if there are an even number of values. So let me show you what that means. Again, if you need to stop the video for a second to catch up your writing, you can do that. So let's say my data in order was 3, 4, 7, 10, 15. It's in order smallest to largest. My middle value, literally just the one in the middle, when they're lined up, is 7. So that would be my median in that case. Now instead, what if I had 3, 4, 7, 10, 15, 20? Well, now when I find the middle values, I have 2 in the middle because they're an even number of numbers. So they're going to be 2 in the middle. So I find their mean, which means I add them up and I divide by 2. So 17 divided by 2 equals 8.5. That is going to be my median in this case. And again, we'll do an example in a minute. The mode is the number or data value that occurs most often. So I always think of mode, the MO, as being most often. There can be one mode, more than one mode, or no mode in a data set. Okay, so let me give you some examples here. If my numbers are 1, 1, 2, 3, that's my data set. The mode is 1. It's what happens most often. If I have 1, 1, 2, 2, 3, there are actually 2 modes now. There are 2 modes that happen more often than anything else in the same number of times. So my modes are 1 and 2. If I have 1, 1, 2, 2, 3, 3, this is where it can get a little tricky. There's actually no mode here. Just because everything happens more than once doesn't mean it's the mode, it's whatever happens most often. As soon as everything happens the same number of times, there's no mode, there's no winner. Okay, so kind of keep that in mind when you're thinking about mode. Here's an example. It says the forecasted high temperatures in degrees Fahrenheit for the first 10 days of July 2025 for Dryden, New York are given below. Find the mean, median, and mode of this data. Show your work. So I am going to go through these. If you want to just pause the video, try it on your own, then you could even just fast forward a little bit and see the answers and check your answers if you'd like, whichever is going to help you more. So to find the mean, I'm going to add these all up. So we're going to take 82 plus 77 plus 73, 73, 80, 86, 87, 79, 77, and another 77. And we get 791. So I add them all up. If you need to write yourself some notes about what we're doing, go ahead and do that. And then it said there were 10 days. There are 10 values here, so I'm going to divide by 10. And my mean is going to be 79.1. The median, I have to put them in order, remember, from smallest to largest. So 73, 73, I'm just going to kind of check them off as I do it. And then we have 3 77s, 79, 80, 82, 86, and 87. Now when I rewrite things for the median, I like to double check that I found them all. I know there were 10 there, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wanted to make sure I didn't miss any. So now it's 10, I want to find the middle values. If I count in from both sides, there are an even number of values, so I know I'm going to end up with 2 middle numbers, 77 and 79. So then I take the mean of those two. You might be able to just in your head know what's in between those, but the sort of formal way to do it is we could add those up and get 156. 156 divided by 2 is going to be 78. So my median is 78. Notice that my median is 78 even though 78 is not actually one of my data values. And the mode, I can look at where I have it in order here. This can kind of help me so I can look at this. And what's happening most often is 77. 77 happens 3 times and nothing else happens 3 times. 73 happens twice, but not as much as 77. Okay, so hopefully that was like a little review or new information for you. On the back of these notes, it's just a couple questions for you to think about. Nothing you have to turn in, but if it helps you think about what some things are that you learned or understood better. And then are there any topics or examples you didn't understand? If so, you can jot yourself a little note and then you can ask about those in class. Okay? Thank you for watching this video and I will see you next class.